Hey, all you cool cats and kittens. Welcome back to Weld.com. So today we're going to talk about blueprints and shop drawings. Before we do that, we want to go ahead and take a moment to thank today's sponsor, which is Skillshare. Skillshare is an online community for creative people who get together and they want to learn more interesting skills and kind of take the next step in their creative journey. There's all kinds of classes on there that you could take, such as underwater basket weaving, or photography, video, freelancing, all kinds of stuff. For those of you that are staying at home right now, don't have a whole lot to do, now is a great time to learn a new skill so that when you get back into the market, you become more employable. The first 1,000 of our viewers to click on the link below is going to get a 2-month free trial. Thank you, Skillshare, for sponsoring today's video. All right, guys, let's get into it. I'm Ron Burgundy. Okay, so here's a typical print that we have here, just for a random widget that we're going to go ahead and construct this. But before we do that, we have to figure out how big each part is, the shape of each piece, and then where they're all actually going to go. Now, we all understand our welding symbols because we did a previous video on that. So make sure you go back and check those out. We'll get into that a little bit later. First thing we want to look at is right here. This is called an isometric drawing. Okay, it's usually set at about a 30-degree offset, and it's a 3D representation of the part. Typically, you won't have this in a shop drawing or a set of blueprints. For some reason, they tend to leave that out, and we are left with what's called the orthographic projection, and that is these three parts right here. Now, usually on a set of prints, the top part is always up here. That makes sense, right? Because it's the top. This is the bird's eye view of the object. This is called the front view, and it has the greatest amount of detail. See, it shows the most amount of information that we have to learn about our part. Like I said, this is typically not here, so we don't have that 3D representation. So what we have to do is look at this in the flat position, you know, to where you can only see one side or the other at a time, and kind of build that 3D model in our head. And you can do it. It just takes a little bit of time. You have to learn how to look at these objects. Okay, and then this one over here is called the right side view. So that means we took that object and literally rotated to the right, and now we are looking at it in this direction. Okay, so this is the right side view. Let's go over some of the lines. There's some basic lines on here. Object lines are going to be these bold lines, right? That's basically the outer perimeter of the shape that we're going to be working with. So most of the stuff on here is plate, so you can see these hard black lines here are object lines. Okay, so that is the edge of the piece that we're going to be working on. Next up, we have hidden lines. Now, these are lines that we can't see. So it's almost as if we have x-ray vision and now we're able to see. So right here is a hidden line. This hidden line is directly in line with the edge of this piece that's going to go here on the bottom. Same thing here. I have some hidden lines in this area as well as here. Okay, so I can tell that this is a hidden line, so there's obviously some sort of through hole, but I don't know the shape of that hole. But if I turn it to the right-hand side, I can see that that, in fact, is a 1-inch diameter circle. Okay, so those are our hidden lines. Next, we have our extension lines and dimension lines. Now, the extension lines go right off of our object lines. Okay, they're usually offset by about a 1/16 of an inch, and they tie right into our dimension lines. Our dimension lines tell us exactly how long or wide or thick that piece is going to be. So we have our extension lines. That's just an extension of the object. The extension lines should never touch the object lines because then it's part of the object. So we don't want that. You'll notice that there's a gap in between all of those. But these are our dimension lines. So we have some up here, across here, down here. Other parts of the blueprints we have, or other parts of the prints or shop drawings, we have what's known as notes. Notes are usually in the upper right-hand corner or on the right-hand side of the drawing. And it's just some things that we want to consider as we're going through to build this. So, for instance, note number 1, all dimensions U.S. customary unless otherwise specified. The material is going to be 3/8 thick, plain carbon steel materials, so on and so forth. Right here is important because we're going to get into this here in a minute. The welder shall prepare a bill of materials in U.S. customary units of measurement prior to cutting. So we're going to go ahead, I already have that done, but this is called the bill of materials. And this can either be down in this area or in the far upper right-hand corner, depending on who's drawing the prints. Down here on the right-hand side, or usually across the bottom, we have the title block. The title block is going to give us dimensions and tolerances. It's going to let us know the revision dates. If there was anything updated on this set of prints, your revision dates are going to be on here. If it's signed and sealed by an engineer, that's going to be on there along with the engineered stamp. So you'll have a sealed set of documents. So these are legally binding construction documents once they get that seal on there, and that's the way you have to perform the way that it's laid out and drawn. You have to perform to those specifications. And then there's usually a title. What project are we working on? So this one's called Entry Weld Workmanship Qualification. And then there's usually a page number and a drawing number down at the bottom right hand side. And then here we have scale. Scale on this is 1 to 2. We're not going to worry about scale because I don't work off of scales because I have my dimensions on here. Most of the time you're going to see these prints, you're going to have something down here where it says scale, and it's going to say NTS. That means not to scale. Throughout my entire construction experience, I've never used, well, I take that back. I've only used scale drawings a couple of times because pretty much everything is dimensioned. We don't have to scale anything anymore. But scaling just means it's not full size. So obviously, take for instance this one dimension line right here tells me that that's 8 inches. Sorry fellas, that's not 8 inches. Okay, so this is not to scale. So what we're going to do is we're going to go through, build our bill of materials. So we have item numbers or piece marks, or I'm sorry, we have item numbers, what number these are going to be. Part numbers, so we can actually label each part. So when they go to assembly, we'll know which piece is going to what spot. A description, so part A, for instance, 3/8 by 6 by 8 inches, mild steel A36, and there's going to be one of those because this is our quantity. So anytime we have more than one, that's going to be listed in here as well. So we're going to go ahead and develop a bill of materials. We'll kind of go through what a shop drawing would look like. Let's start off with item number 1, and that's going to be part 1A. So we'll go ahead and draw that out. Okay, so part number 1 is telling me is 8 inches long because I'm looking at right here. This tells this the indication. Here is part number 1. I'm just going to follow the object line all the way around. Engineer kind of made a mistake right here. This should be a hidden line because I shouldn't see the seam where these two pieces are together. So part number 1 goes all the way to here to here. So that's 8 inches. So I know that that part is 8 inches long. Now it doesn't tell me the width because I don't have depth here. So I actually have to look at my top view, which is up here. And it tells me the depth of piece number 1 is going to be 6 inches. So this is just a plate, 6 inches wide, 8 inches long, and as we read in the notes, it's going to be 3/8 thick material. All right, so this is the piece that we've already cut out. So this would be the top view, okay, front view, and then if I rotated it, right side view. So that's just 3 ways to look at one plate. So you can start to see how you develop a 3D image of this in your head. So that's, once again, that's top view, lay that back 90 degrees, front view, rotate it 90 degrees, and right side view. Let's move on to piece number 2. We'll just do a couple of these so you can get the basic concept, and then we'll get into the fancy stuff. So now we actually have to do a little bit of math to figure out the dimensions of piece number 2 because it doesn't dimension this out, and this is very common in a set of prints not to have everything dimensioned out. So I need to figure out the width of this piece. So in order to do that, I have to follow some clues, right? I know that overall, this piece from end to end is 11 inches. Well, then I have to come down here. That tells me my edge of my piece is right here. So there's a 2-inch offset right here. So I just take my 11, subtract 2. That's going to give me 9. Okay, so from the end of this plate to the end of part number 2 is 9 inches. But this right here, this 5-inch dimension, tells me the left side of my plate. So now I can deduce that from this point here, which is 5 inches, over to this point here, which is 9 inches, is 4 inches. So that plate is 4 inches wide. How long is it? Got to go back up to my top view. 6 inches long. Okay, so we're all good there. So this part number 2 is going to be 6. Figured out the math on this. It's 4 inches. Here we have part number 2. Okay, 4 inches wide, 6 inches long, 3/8 thick. So if we look at it from the top, looking down, bird's eye view, that's the top view. Okay, we can actually see the whole plate for the most part. Rotate it down to the front. That's where I get that 4-inch width. Right side view, now this piece is 6 inches. Okay, so when we go over here, even though this piece isn't dimensioned, I know that it is 6 inches because I have a hard stop here. And up here, it tells me that these plates right here are 6 inches. So they're not typically going to dimension the same part several times. They're only going to give you the dimension you need one time to kind of give you some clarity, so just so you don't have numbers all over the page. Okay, so that's part number 2. Part number 3 and 4, you're going to find those dimensions the exact same way. This one right here is just 2 by 6. Nothing special about that. We're going to get into how to detail that part out here in a moment. And then part number 3, same thing. We don't have to worry about that. You're going to find those dimensions the same exact way you found the rest of them. You have enough information in here to do your math and figure out exactly how tall piece number 3 is, right? Because we already know it's 6 inches tall, and we just subtract 2 inches, so it's going to be 4 inches up to this mark right here. Same thing with our width. We're given 6 inches here, so that's how you find the dimensions of piece number 3. Once again, it's just a flat plate. Nothing special about it. We'll check out the welding symbols here in a minute to figure out exactly how to detail everything. Let's move on to part number 5. All right, so moving on to piece number 5, okay? I don't have any height dimensions, but here's the outline of part number 5. Okay, it's kind of got like an L shape to it. But I don't know how tall it is because it's not depicted here on the front view. And I can't see height on my top view. So now I have to resort to my right side view. So if I look over to the right side view, it tells me that overall it's 6 inches tall. And then I have an object line right here. So what could that be? That's not a hidden line, that's an object line. If I look back over here, I can see where it's cut out. So this object line that we're looking at on the right side view is this line right here, okay? Now if you notice, if you drew a straight line from here to here all the way across, that's where that mark is hitting, right here, okay? So I have an overall height of 6 inches. I have a width. We need to figure out the width. That's pretty simple because if I go from here to here, it doesn't tell me exactly what it is, but it tells me that it's 11 minus 6. So that's 5 inches wide, right? You just take 6 minus 11, boom, I'm at 5. So now I figured out that part number 5 is 5 inches wide, 6 inches tall. I come down 2 inches, come in 2 inches, and go straight down. So when I cut it out, that's piece number 5. So a top view would be right here. I can see my dotted line, so there's going to be a dotted line right in here. That's my hidden line that's showing the object line right here in the back. Okay, it's rotated. You can't see that hidden line, but it tells me something's back here. It's not a full plate, right? Because I have that hidden line right in this area. And when I rotate it to the front view, that shows me exactly what it is right here. And then when I go to my right side view, that's where this hidden line is. So this hidden line right here is actually the edge of that plate. So that's part number 5. Okay, so now we're on to part number 6 right here. Remember, we have the hidden lines in here. We have to figure out exactly what's going on. I have an object line, 2 hidden lines, so I know that there's something's missing here, right? Something's, I can't tell the whole story. So I look at my right side view, this tells me that it is a 1-inch circle. Okay, so I know I have a 1-inch circle in here. Well, how do we draw this? How do we figure that out? How do we figure out the dimensions of this piece? Well, if I go over here to my right-hand side view, I know that from here to here, because of my top view, is 6 inches. So this whole piece is 6 inches wide, and then I'm coming in 1/2 inch. So the width of this is going to be 5.5. Okay, so I know I have a 5.5 width now. And then I have to figure out what my overall height is going to be. All right, so to figure out the height on piece number 6, I know that this is 6 inches overall, and I have a 1/2 inch offset right here, and it says TYP. Now TYP is a standard abbreviation for typical. That means everywhere where you see this, that's going to apply. This situation right here. So it's a 1/2 inch in here and a 1/2 inch in here. So now I know I'm down to 5.5 inches. I know that both of these plates are 3/8 thick. If I add those together, I'm at 3/4. So if I subtract 6 minus the 2 3/8 plates, and then that 1/2 inch offset, I'm left with 4 3/4 of an inch height. Come in on both sides, 3/4 of an inch typical, so that means 3/4 of an inch here, 3/4 of an inch here, and then I just strike those 2 lines together, and I end up with piece number 6. So once again, here is my top view. I can see the hidden lines, which is the edges of that circle in there that I can't really see if I'm doing the bird's eye view. Rotate it down to the front. Okay, I would have hidden lines here and here, and then my object line, which is shown here. So hidden line for the circle, and then object line right here. And then a right side view. Okay, so that pretty much shows me everything I need to know. Okay, so now that we have our bill of materials built, we went ahead and cut out all the pieces. And typically what I do is I'll just kind of sketch everything out. I'll draw it out just like we did over here. I'll draw each piece out, make sure the dimensions are correct. Go ahead, cut them out, do any, clean off, deburr, all that good stuff. Now what we have to do is we have to start prepping the materials because there's a lot of beveling that has to go on here. So the first thing I'm going to do is I'm going to start off with item number 1 or piece 1. That is our 6x8 plate. And if I look at this print right here, it tells me that there's a 45-degree bevel. Now, I'm going to go out on a limb here and say, once again, the engineer screwed up. We all know our welding symbols. We should have a material break line, or a break line right here telling us that that's the material that we need to prep. So on that long edge of part number 1, I'm just going to bevel this 45 degrees and face it down because I have the vertical pieces that are going to sit here, and I'm going to put a grooved weld in here. One side is going to be beveled 45 degrees. The other pieces are just going to match up square. So part number 1 needs a 45-degree bevel all along the entire back side of it. That's from here to here because of what this welding symbol right here tells me. Piece number 2 doesn't look like it gets any beveling whatsoever. This is part number 2 here. Again, that's my isometric. It's not going to be in there, but I do have some weld symbols that I need to pay attention to. I'm getting some 1/4-inch fillet welds, 2 inches on 4 inches. So these are going to be staggered. Uniformly staggered. Part number 3 right here, that's just going to be a square plate, but I do have some beveling that has to take place here, and I know that because I'm looking at this part right here. Now that's going to be a single V butt groove or single V butt joint with 45 degrees. So the back side of part number 3 has to be beveled 22.5 degrees. So we'll get that beveled as well. Part number 5 is this side right here. So this thing right here needs to have the matching 22.5 degree bevel to meet up with part number 3. So let's go ahead, we'll start hitting up, cleaning all these up, get them beveled and get them prepped to weld, and then I'll show you guys some tricks how to do layout and get the material cleaned up so we can go ahead and weld it together. All right guys, so what we're going to do with this, I'm just going to go ahead and take the Victa grain, got it on the grinder, I'm going to go ahead and knock this down. I'm going to try and hit a 45-degree angle and just get it pretty close. Try to maintain that hard edge so we don't have any gaps in there. And just strip this back. We'll go through each piece, take care of all the beveling, and then we'll do some layout and then material cleanup so that we can get ready for weld. All right, so we got our 45-degree bevel on this piece. Let's go ahead and prep up the remaining pieces. Piece 3 and 5 and 4 are all going to be part of the same weld seam, and we know that it's a 45-degree angle. So what I'm going to do is I'm just going to lay piece number 3 and 4 side by side, bevel those at 22.5 at the same time, and then I'll do the back side of piece number 5 as well, and we will put, this means it goes on the other side, so this is going to be on the side facing us, so it'll be on the inside here. Okay, so we're going to go ahead and get that stuff prepped up. So as you can see, I have pieces 1, 3, 4, 5. 1 is actually going to sit on top of these. Okay, so as you're looking at it, you're kind of looking at it from the front view. But everything's in line here, so I'm just going to lay everything out where I need to take off all the mill scale to where I can weld all this stuff up, and then I've done my material preparation correctly prior to welding. I also want to figure out where piece number 6 is going to go. I know it's going to be somewhere in here. So if I look at the print, it tells me it's going to be offset from the edge of plate number 5, 3.811 inches, which equates to 3 13/16. So I'm going to measure over 3 13/16, come down from this top edge, that specified distance of a 1/2 inch, right? So I'm going to come down a half inch from here, 3 3/16 in, make a square mark. And what I'm going to do is I'm going to center punch where I'm going to make my marks and center punch those, because I only need to take off as much mill scale as the weld is going to require. I don't want to waste the time of taking mill scale off everything, okay? Unless you can get all your parts bead blasted, then you can skip this step. But for this part, I'm going to go ahead and just lay out the areas where I'm going to put everything together. I can take the mill scale off, my marks will still be left there, and then I can do the final assembly. Another thing I have to do is figure out where piece number 2 goes. Now I know that piece number 2 down here, that left-hand edge is going to be 5 inches off the far left-hand edge of plate number 1. So I'm going to measure in 5 inches. So that's from here, measure in 5 inches. That's going to be the left-hand side of this plate. I'll center punch that, get everything cleaned up, because remember we have our stitch welds that we're going to put in here, or our intermittent fillet welds. So let's go ahead and do that. I'll measure that 3 13/16 in. So that's what I already have set up here on this combination square. So I'm going to just make a mark here. That's where my plate's going to go. So here's my top. There's that right-hand side. This piece is going to sit just like that. If everything's correct, I should have 3/4 of an inch right down here. And nailed it. So we're all good. We're tracking. Go ahead and center punch these. So I'm going to take that 4 3/4 plus that 1/2 inch distance right here. That gives me 5 1/4. So I'm going to measure down 5 1/8, 5 1/4. Just make me a little tick mark, and I'm going to center punch that part as well. So to figure out where we're going to go with plate number 2, I'm going to do that 5 inch offset right quick. So now I know exactly where piece number 2 goes. I can get rid of the mill scale. So now I'm just going to kind of, this is what I do. Might help some of you guys out. I know that I want to take my mill scale off of right here. I'm going to take it off this edge, over here. And this just prevents me from wasting too much time grinding. And then I'm going to go right in through here, take off about 1 inch. Same thing with this. This piece here, get weld on both sides. So I'm just going to take off all this. This area is not getting welded here, so there's no point taking that off. And then I know that right up here on my bevels, I'm going to take all that stuff off as well. And then I'll go ahead and pull it off the back too. So now I'm just going to go through and kind of tack everything together. So I have this at my 5 inch mark. I'm flush down here, so I'm going to go ahead and tack that in because I can lift this as one piece. And then I'll get a couple tacks on these so they don't go anywhere. Get this guy where he's supposed to go. Keep carrying on. All right, so going through this print, there's one thing I didn't anticipate. Come on down here. All right, when I put this together, see I have this groove weld in here? Once I put this plate into its final resting place, I won't be able to do that with that groove weld teeter-tottering. And I can't tack this all together because I'm going to miss, 3/4 of an inch of weld. So I'm going to go ahead, clamp this to the table, run the groove weld. I'll take that Victograin, knock that 3/4 inch down flat, and then I'll be able to do that final assembly. Should be able to get everything else tacked up and ready to go. All right, so as you can see, I went ahead, I just did that first about 1 1/4 inches. If I run that whole thing, I'm probably going to turn this thing into a banana. So just did that first little bit. I'm going to knock that back off with that Victograin. Then I'll be able to tack this on there once I'll be able to get this in there. And this is actually going to help stiffen that plate up. All right, so I went ahead, I got that cleaned out, and then I noticed I didn't take enough of the mill scale off over here, so I got that cleaned up. You can go ahead and put this in place. Get it tacked up to where it's not going to move anywhere, and then we can start doing some weld out. Ta-da! All right, so now we just have the welding symbols to worry about. So we have a couple of groove welds to fill in, and then we get a 1/4 inch weld on both sides on this, this piece, top and bottom. So we'll catch all 4 of these, 1/4 inch, and then we have the 1/4 inch 2 on 4 centers. Now this is 6 inch wide plate, so if I put 2 inches at the front, 2 inches at the back, they're going to be 2 inch welds at 4 inches on center. So that one's pretty simple. So we'll go ahead and knock that out, tie everything in, and we should be good to go. All right, so we got it all welded out. Everything's good. So again, just go through, Check out your bill of materials. If you don't have one, develop one for yourself. Make sure you cut everything out according to specs. Get all your bevels in there. Do your prep work. Try that little trick I showed you with center punching all your marks, and then you can go back and take off all your mill scale, or prep your material, whatever the case may be. Get everything tacked up, kind of figure out your sequence of operations. Like that one groove weld that was going to screw me up because I didn't anticipate that. I should have saw that, but when I went to assemble it, I noticed, hey, if I put that together, I'm going to miss 3/4 inches of that groove weld that I'll never be able to get back. So I had to make that groove weld before I did the final assembly. So just kind of take some of that into consideration. The only way to get good at blueprint reading is to continue building them. Check out Skillshare, see if they have any videos on there on different print reading methods. You can go through and check out their library. There should be some other stuff in there. Pick you up a book on how to weld detail drawings. That is a great book. It's good reference material. Go through the additional lines because there's more lines than what we just covered here. There's phantom lines, short lines, break lines. There's a whole menagerie of stuff. So this is just like an introductory video to how to read blueprints and shop drawings. Covered the basics, so you guys should have a pretty good understanding how to assemble small parts and objects. Hope this video helped you guys. Appreciate you watching. Don't forget to like and subscribe. And until next time, make every weld better than your last.